When upgrading the electrical service in townhomes with a common water supply, the question of proper grounding arises. In a scenario where two townhomes share a common wall and have separate electrical services on opposite ends, with water entering on one side and branching off to individual water meters in each unit, it's crucial to understand the grounding requirements. The specific question is whether a ground wire needs to be run through both homes to the point where the water enters the building, or if grounding at the point where the water enters the second home is sufficient. In this instance, it is advisable to follow the inspector's guidance and ground the water pipe at the point where it enters the second home. The reasoning behind this recommendation lies in the fact that the water piping is already bonded through the hot water heater. This bonding creates an effective path to ground for the entire water system within the second home. Running an additional ground wire through both homes to the initial water entry point is not a mandatory requirement. Several factors contribute to this determination. Firstly, the purpose of grounding the water pipe is to ensure that any fault current that might occur on the metallic water piping system has a low impedance path back to the electrical source. This low impedance path facilitates the quick operation of overcurrent protective devices, such as circuit breakers or fuses, thereby minimizing the risk of electrical shock or fire. Secondly, the National Electrical Code, or NEC, provides specific guidelines for grounding and bonding of electrical systems. While the NEC mandates the grounding of metallic water piping systems, it also allows for alternative methods of achieving effective grounding. The key requirement is that the grounding method provides a low impedance path for fault current. Thirdly, the bonding of the water piping system to the electrical system through the hot water heater provides this low impedance path. The hot water heater is typically connected to the electrical system via a grounding electrode conductor, which is connected to the grounding electrode system of the home. This connection ensures that the water piping system is effectively grounded. Fourthly, in situations where the water meter is located outside the home, the NEC requires that a bonding jumper be installed around the water meter. This bonding jumper ensures that the continuity of the grounding path is maintained, even if the water meter is removed or replaced. Fifthly, it is important to consider the potential for corrosion on metallic water piping system. Corrosion can increase the impedance of the grounding path, which can reduce its effectiveness. For this reason, it is important to ensure that the grounding connections are properly made and maintained. Sixthly, it's crucial to consult with a qualified electrical inspector or engineer to ensure that the grounding system is properly designed and installed. The inspector can assess the specific conditions of the installation and provide recommendations that comply with the NEC and local electrical codes. Seventhly, when performing any electrical work, it's essential to prioritize safety. Always disconnect the power supply before working on electrical circuits or equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Eighthly, understanding the different types of grounding electrodes is important. The NEC recognizes several types of grounding electrodes, including metal underground water pipes, ground rings, rod and pipe electrodes, and plate electrodes. Each type of grounding electrode has its own specific installation requirements. Ninthly, the size of the grounding electrode conductor is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the grounding electrode conductor based on the size of the service entrance conductors. Tenthly, the grounding electrode conductor must be connected to the grounding electrode system in a manner that ensures a permanent and effective ground. The connection must be made with a listed connector or by exothermic welding. 11thly, the grounding electrode system must be located as close as practicable to the service entrance. This minimizes the length of the grounding electrode conductor, which reduces the impedance of the grounding path. 12thly, the grounding electrode system must be protected from physical damage. The grounding electrode conductor must be run in a conduit or otherwise protected from physical damage. 13thly, the grounding electrode system must be accessible for inspection and testing. The grounding electrode conductor must be visible or accessible for inspection and testing. 14thly, it's important to understand the difference between grounding and bonding. Grounding is the connection of the electrical system to the earth. Bonding is the connection of metallic parts of the electrical system to each other. 15thly, the purpose of bonding is to create a low impedance path for fault current. This helps to ensure that overcurrent protective devices operate quickly in the event of a fault. 16thly, the NEC requires that all metallic parts of the electrical system that are likely to become energized be bonded together. This includes metal conduit, metal enclosures, and metal equipment. 17thly, the bonding conductors must be sized according to the NEC. The size of the bonding conductors is determined by the size of the circuit conductors. 18thly, the bonding conductors must be connected to the metallic parts of the electrical system in a manner that ensures a permanent and effective bond. The connection must be made with a listed connector or by exothermic welding. 19thly, it's important to understand the role of the main bonding jumper. The main bonding jumper is the connection between the grounded conductor and the equipment grounding conductor at the service entrance. 20thly, the main bonding jumper provides a low impedance path for fault current back to the source. This helps to ensure that overcurrent protective devices operate quickly in the event of a fault. 21stly, the size of the main bonding jumper is determined by the size of the service entrance conductors. The NEC provides tables that specify the minimum size of the main bonding jumper based on the size of the service entrance conductors. 22ndly, the main bonding jumper must be located at the service entrance. This minimizes the length of the bonding conductors, which reduces the impedance of the bonding path. 23rdly, it's important to understand the role of the equipment grounding conductor. The equipment grounding conductor is the conductor that connects the metallic parts of the electrical system to the grounding electrode system. 24thly, the equipment grounding conductor provides a low impedance path for fault current back to the source. This helps to ensure that overcurrent protective devices operate quickly in the event of a fault. 25thly, the size of the equipment grounding conductor is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the equipment grounding conductor based on the size of the circuit conductors. 26thly, the equipment grounding conductor must be run with the circuit conductors. This ensures that the impedance of the grounding path is minimized. 27thly, it's important to understand the role of ground fault circuit interrupters, or GFCIs. GFCIs are devices that detect ground faults and interrupt the circuit. 28thly, GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. This is because these locations are more likely to have wet conditions, which increases the risk of electrical shock. 29thly, GFCIs can help to protect people from electrical shock. They can also help to prevent fires caused by ground faults. 30thly, it's important to test GFCIs regularly to ensure that they are working properly. The NEC requires that GFCIs be tested at least once a month. 31stly, understanding surge protection is also critical. Surge protective devices, or SPDs, protect electrical equipment from voltage surges. 32ndly, voltage surges can be caused by lightning strikes, power outages, and other events. 33rdly, SPD can help to prevent damage to electrical equipment caused by voltage surges. 34thly, SPD are available in a variety of types and sizes. The type and size of SPD that is needed will depend on the specific application. 35thly, it is important to install SPD properly in order to ensure that they are effective. The NEC provides guidelines for the installation of SPD. 36thly, when dealing with townhomes, there might be specific requirements depending on how the electrical services are configured. If each townhome has its own separate electrical service, and the water pipe enters each unit independently, then grounding the water pipe at the point of entry for each unit is typically sufficient. However, if the electrical services are interconnected in any way, or if there are shared grounding electrodes, it's crucial to consult with a qualified electrical inspector or engineer to ensure that the grounding system is properly designed and installed. 37thly, always refer to the latest edition of the National Electrical Code and local electrical codes for specific requirements. Electrical codes are constantly evolving to reflect new technologies and safety standards. 38thly, proper grounding and bonding are essential for electrical safety. They help to protect people from electrical shock and prevent fires caused by electrical faults. 39thly, if you have any questions or concerns about grounding and bonding, it's best to consult with a qualified electrician or electrical engineer. They can assess the specific conditions of the installation and provide recommendations that comply with the NEC and local electrical codes. 40thly, remember, electricity can be dangerous. Always take precautions to protect yourself and others from electrical hazards. 41stly, double check all connections and ensure that all equipment is properly grounded before energizing any electrical circuits. 42ndly, in summary, for townhomes with separate electrical services and a common water supply, grounding the water pipe where it enters each unit, particularly with bonding through the water heater, is generally acceptable, provided it meets NEC and local code requirements. Always consult with an inspector for confirmation.